Now we will learn about the various circular motion. Let us start with the simple one, that is uniform circular motion. In the uniform circular motion, the speed of the object will be constant. Let's say an object of mass m is moving on a circular path of radius r with constant speed v. Here, to maintain the circular path, one force is required that is acting on the object towards the center of the circle. This force is called centripetal force. This centripetal force is given by mv square by r. So the centripetal acceleration will be v square by r. The relation between the angular velocity and linear velocity is v is equals to omega r. Here omega is the angular velocity and its SI unit is radian per second. Remember, in this case the speed is constant but velocity is variable. The second type of motion is non-uniform circular motion. In this case, the speed is not constant. The force required to maintain a circular path is called centripetal force. Let's say an object of mass m is moving on a circular path of radius r. At this point, the speed of object is u, and at this point the speed of object is v. That means the speed of object is changing, so it is non-uniform circular motion. Now, to maintain the circular path, we require centripetal force, but to change the speed of object, we require another force that is called tangential force. It is called tangential force because it will act along the tangent of the circle. If object is moving in this direction and we apply the force in same direction of motion, then speed will increase, and if we apply the force in the opposite direction of motion, then speed will decrease. Let's see, this is the centripetal acceleration AC and this is the speed. If tangential acceleration is acting in the same direction as that of speed, then the resultant of tangential acceleration and centripetal acceleration will give us the net acceleration. So net acceleration is given by under root AC square plus AT square. Now, if this is the direction of tangential force and velocity is in opposite direction, still the resultant acceleration will be same, A in this direction only, but in this case the angle between velocity and net acceleration will be obtuse. So if v and t are in same direction, then speed will increase and the angle between A and V is acute. Here we can see speed and acceleration are, velocity and acceleration are in same direction, speed is increasing, so angle between acceleration and V is acute. If V and AT are in opposite direction, then speed will decrease and the angle between A and V is obtuse. As in this case, this is tangential acceleration and velocity. they both are in opposite direction, so the angle will be obtuse. Now if we have taken the center as origin, so this will be the direction of position vector r, and this will be the direction of centripetal force Fc. So if center of the circle is taken as origin, then angle between centripetal force and position vector of the object is 180 degree. Don't get confused, it is not 0 degree, it is 180 degree, because they both are directed in exactly opposite directions. Now let us see example based on circular motion. In this situation, a block of mass m is kept on a horizontal turntable at distance x from the center. The coefficient of friction between block and table is given mu. We want to find the maximum value of omega so that the block does not slip. Here the block will rotate with the turning table. To rotate, the centripetal force is required. Let's say the centripetal force is mv square by r. In this direction, centripetal force will act, and in the opposite direction of the applied force, the frictional force will act. So the frictional force will be mu into normal reaction, and that is equals to mu into mg. If the velocity of this table increase to the certain value, then the centripetal force will be more than the frictional force. In that case, this block will start sliding towards the center, but we don't want it. We want it to slide with the turntable only. So the maximum value of centripetal force, that is mv square by r, that should be equal to mu mg, but we know v is equals to omega r, so m is equals to omega square r square divided by r is equals to mu mg. This m will get cancelled out, one r will get cancelled out, so omega will be equal to mu g by r, omega square. So omega will be equal to under root mu g by r. So this will be our answer. This is the maximum value of omega. Let us see example on circular motion and tension both. There are two particles, each of mass m. They are moving in a horizontal circle with same angular speed. If both strings are of same length, then what is the ratio of tension in this string T1 by T2? This is string T1, this is string T2. They both have same length. Let's say the length of this is r, so length from this will be 2r. This is r plus r, that will be 2r. They both are having same angular velocity, but the linear velocities will be different. Let's say the linear velocity of this first object is v1 and of this is v2. So v1 is equals to omega r and v2 is equals to 2 omega r, as the radius is 2r. Now the tension force, if we draw the free body diagram of this block, then the tension force in this string will be due to the motion of both of the particles. So T1 is equals to m omega square r, that is due to first particle, plus m omega square 2r, that is due to second particle. So T1 will be 3m omega square r. Now if we draw the free body diagram of second particle, the tension in this string is only due to this particle. So T2 will be m omega square 2r. Taking the ratio of 1 and 2, we will get T1 by T2, that is equal to 3 by 2. Here keep this in mind, they are moving with same angular speed and not the same linear speed. The third type of circular motion is the conical pendulum. In the conical pendulum, a bob is connected with a string. It is fixed at a point and this bob will move in such a way that a cone is formed. This is called conical pendulum. Let's say mass of the bob is m and the length of the string is L. It is moving in a circle of radius r. At an instant at this point, it is making an angle theta with the vertical. So if we write the forces, in the downward direction, force mg is acting. In this direction, along the string, there will be tension. If this angle is theta, then this angle will also be theta. So this component will be t cos theta and this component along the horizontal will be t sin theta. This horizontal component of tension force will provide the centripetal force. So as the situation is balanced, then t sin theta is equals to mv square by r and t cos theta is equals to mg. Taking the ratio of this two, we will get tan theta is equals to v square upon rg. So from this, the linear speed of the conical pendulum bob will be equal to under root rg tan theta. Now we want to find the time period. As it is moving with constant speed, the time period is given by total distance upon speed, that is equal to 2 pi r upon v. So we can write 2 pi r upon v is given by under root r g tan theta. So time period will be 2 pi under root r upon g tan theta. This root r and root r will get cancelled out. But from this we can write that r is equal to, this is the length of string and this is the radius, this angle is theta. So we can write r is equals to L sin theta. So putting r is equals to L sin theta and g tan theta is equals to g sin theta upon g cos theta. This sin theta will get cancelled out. So we will get time period is equals to 2 pi under root L cos theta by g. This is the time period of conical pendulum. This time period is directly proportional to L, root L, and it is inversely proportional to root G. The fourth type of circular motion is the motion of car on a level circular road. The meaning of level circular road is that there is no height difference between two sides of the road. Let's say this is a level circular road of radius r. The car is moving on the level road in circular path. The frictional force will act in the inward direction. That means the frictional force will provide the centripetal force. In the downward direction, force is mg, and in the upward direction, force is normal reaction. Here the static friction provides the centripetal force. So we can write frictional force is equals to mv square by r. But this frictional force F should not overcome the limiting friction. If limiting friction is overcome, then this car will start moving towards the radius. It will start moving towards the center. So for that, the mv square by r should be less than or equal to mu s n. This is the limiting friction Fl. So v square should be equal to mu s n r upon m. But n is equals to mg. So v square is less than or equal to mu s mg r upon m. This m will get cancelled out. So v square will be less than or equal to mu s rg. So the maximum velocity, for the maximum value we will write the equal sign here. So v max will be equal to under root mu s rg. It is not possible for a car to move on level circular road which is perfectly smooth. So note this thing. It is not possible for a car to move on perfectly level, smooth, circular road. It has to have some friction, because if it is perfectly smooth, then mu s will be 0, and if mu s is 0, then v max will also be 0. Let us see one example on it. In the question, find the maximum speed with which a car can turn on a bend without skidding. That means we want to find the maximum speed. The radius is given 20 meters, mu is given 0.4 and g is given 9.8. We have just derived the formula for maximum speed, that is v max is equals to under root mu r g. So v max will be equal to under root mu is given 0.4, r is 20 meters and g is 9.8. Simplify this, we will get v max is equals to 28 meter per second. Now the fifth type is the motion of car on a banked road. That means the road is circular and it is somewhat banked. That means there is a level difference between two ends of the road. Let's say the angle is theta or the slope is theta. Now we will draw the free body diagram of the car. The mass of car is given m. For the reference, I have drawn a dotted line that will show us the inclined plane. This inclined plane is making an angle of theta with horizontal. So this angle is theta, then this angle will also be theta. In the downward direction, gravitational force will act, that is mg. Here, the frictional force will act along the plane in the downward direction, component of which will provide the centripetal force. So this is force F. Dividing this into horizontal and vertical component, this component will be F cos theta and this component will be F sin theta. The force applied by surface on the object is the normal reaction. if this angle is theta, the angle of plane with horizontal is theta, then angle of normal with vertical will also be theta. So divide this normal reaction in mutually perpendicular components. This component will be n cos theta and this component will be n sin theta. Here the required horizontal force or centripetal force is provided by the components of F and N. So we can write F cos theta plus N sin theta is equals to mv square by r. But the friction force should be less than or equal to the mu s n, that is limiting friction. So for maximum velocity, F is replaced by mu s n. So mu s n cos theta plus n sin theta is equals to mv square by r. This is equation 1. Further, we can write n is equals to mg cos theta. Now, for writing vertical forces, here the vertical forces are balanced. So, mg plus f sin theta can be written as n cos theta. So, n cos theta is equals to mg plus f sin theta. From this, we can write n cos theta minus mu s n sin theta is equals to mg. Now, finding the normal reaction from this, we can write n is equals to mg upon cos theta minus mu s sin theta. So, this is equation 2. Put the value of normal reaction in this equation 1. Then we will get mg sin theta plus mu s cos theta divided by cos theta minus mu s sin theta is equals to m v max square by r. This m will get cancelled out, dividing the numerator and denominator terms with cos theta. This sin theta upon cos theta will be tan theta and this will be only mu. So v max will be equal to under root r into g into mu s plus tan theta divided by 1 minus mu s tan theta. This is the maximum speed. Now we want to find the optimum speed. First of all, we have to understand what is optimum speed. The optimum speed is the speed with which the car can move on a level banked road even when the road is perfectly smooth. So for that, if the road is perfectly smooth, mu s is taken 0. So V optimum will be, this is 0, this 0 into tan theta will become 0. So R G into tan theta. So V optimum will be equal to under root Rg tan theta. Now the minimum velocity will be under root Rg into tan theta minus mu s divided by 1 plus mu s tan theta. Now let us see one example on banked circular road. A circular racetrack of radius 100 meter, that is r is equals to 100 meter, is banked at an angle of 45 degree. We want to find the optimum speed and the maximum permissible speed, given mu s is equals to 0.2. The optimum speed is given by under root r g tan theta. So V optimum will be under root r is 100, g is taken 10 and tan 45 will be 1. So V optimum will be 10 root 10 meter per second. Now we want to find the maximum speed. The Vmax is given by under root Rg into mu s plus tan theta divided by 1 minus mu s tan theta. Here theta is 45, so tan theta will be equal to tan 45 degree, that will be equal to 1. So Vmax will be equal to under root R, that is 100, into G, that is 10, mu s is 0.2 into tan theta, plus tan theta 1 divided by 1 minus 0.2. So Vmax will be equal to 1000 into 1.2 divided by 0.8. So Vmax will be equal to under root 1000 into 12 by 8. 4 3s are 4 2s are. So Vmax will be equal to, this will be 500, 500 3s are 1500, root 1500. So Vmax, further simplifying it, it will be 10 root 15 meter per second. Now let us see one more application, that is bending of a cyclist on a level road. Whenever cyclist is moving on a circular track, during the turn he tends to lean in some angle, making some angle with the vertical to maintain the normal reaction with the surface. Here we are drawing the free body diagram of the cyclist. Let's say this point is representing cyclist of mass m. In the downward direction, force mg will act. The reaction will occur due to this surface in this direction. So this is the normal reaction. If this angle is theta, then this angle will also be theta. So this component will be r cos theta and this component will be r sin theta. For the balancing, r cos theta is equals to mg and the r sin theta will provide the required centripetal force. So r sin theta is equals to centripetal force, that is equal to mv square by r, and r cos theta is equals to mg. Taking the ratio of these two equation, this r will get cancelled out. Sin theta upon cos theta is tan theta. This m will also get cancelled out. So tan theta is equals to v square upon rg. This is the angle. Theta is equals to tan inverse v square by rg is the angle made by cyclist with the vertical. Remember, this angle is given with vertical. Let us see one example on that. A cyclist is moving on a circular path of radius 10 meter and with uniform speed 36 km per hour. The angle with vertical at which motorcyclist will bend is, we want to find the angle theta. For that, first we have to convert this kilometer per hour into meter per second. So u will be equal to 36 into 5 by 18, that will be equal to 10 meter per second. Now use this formula, then tan theta is equals to v square, that is equal to 10 square 100 upon r 10 upon g, that is 10. So tan theta is equal to 1. So theta is 45 degree. So he should make the angle of theta is equals to 45 degree with the vertical.